So fallacy number 3, which is my favorite one, or my least happy one, is the holy grail of prioritization frameworks is out there. And this is a real passion project for me. I kind of believe that people shouldn't marry themselves to prioritization frameworks perhaps as much as they do. And the misconception is that you have to have a framework to prioritize everything always. When in actual fact, it's quite unmanageable. If you try to prioritize all of those ideas in that spreadsheet that I showed you, you would be at it for like a day trying to get all the evidence you needed to prioritize those ideas. And then a week later, you might have to reprioritize them all. Every time you run an experiment or you do some product analytics on your site, you're going to reveal new data. And your next priority for what you work on should really change every time new results come in.
Looking like a baddie, I show up and make them stop. Wanna know my name so badly, cause I run this whole block. Flip my hair, move my head, show the world I'm royalty. When I walk by, they be taking bows, cause they know I'm the queen, yeah.
Hi everyone, and welcome to my experimentation session. The title of my session is The Fallacies of A/B Testing. My name's Ellie, and you can see my social links at the bottom there. In this session, we're going to be covering lots of different things that people can get wrong when they're doing A/B testing and how you can potentially overcome them. As a quick introduction to myself, my name's Ellie. I'm a managing consultant and experimentation ninja and digital. We have these things called Untitles, where you can bring more of yourself and your experience into your working and professional environment. So my Untitled is experimentation ninja because I love experimentation that much. I've been in the industry for just over 10 years, and in that time I've helped businesses to ship experiments at scale and create more value from their experimentation programs. In the last year, I won an Agency Experimenter of the Year Award and Financial Services Campaign of the Year Award at the Experimentation Elite Awards in 2022. And also I was shortlisted for the finals of the Experimentation Culture Awards last year as well. So what are we going to be covering today? We're going to be talking through 3 prioritization and planning or product fallacies, 3 statistical fallacies, 2 experiment design fallacies, and then I'm going to review a real value model that will help you to be able to overcome some of the issues that I'll describe in each of the fallacies beforehand. So on to the product fallacies. The first fallacy is that you should collect more ideas or loads of ideas. And the correct approach, the misconception is the correct approach is to create a backlog of all possible ideas, prioritize, and then execute. The truth is that you're just never going to deliver all of them. You could have a backlog with over 100 ideas in a Google Sheet, and actually, by the time you finish prioritizing them all, your priorities might have changed. And actually, between this month and next month, between this year and next year, your priorities are going to change. So your current priorities for your experimentation, for what you want to deliver and release into your website or your app, are going to change, and you need to accept that as part of your process. Take a look at this idea backlog. This is something that I was given as an example when I first joined Photobox. Everyone was allowed to enter their ideas into a massive spreadsheet and to give what they thought would support that idea, to write a hypothesis, to kind of start collecting ideas. That was then turned into a much more formalized hypothesis backlog, which listed all the different reasons why things might be better or worse, or why we should work on them. That was then turned into an idea backlog that was prioritized using RICE. And you can see here on the right that no one ever filled in the RICE framework, because by the time the person had gone from the first spreadsheet to the third spreadsheet, things that are moving in flight had actually changed so much that there was no point in prioritizing any of these ideas. And it would take them so long to do all of that prioritization that they would really struggle. And this was a spreadsheet that had something like 300 ideas in it, so it just wasn't feasible. So how can you overcome this fallacy? So the solution is really to continuously collect data. I know a lot of people talk about continuous discovery, but really it is just always collecting and looking at data, supporting new ideas with evidence. And when you look at ideas, try and disregard ones that you don't have evidence for, or that are too small or don't have enough impact, that you don't think they're going to have enough impact to be able to have a strong impact on the customer. So especially if you don't have enough data to support them, just put them on one side for now. One of the things that you can do is use what's called evidence scores. So evidence scores, the acid test of your ideas, is a concept that is quite common, but Itamar Galad has written it up in a really, really effective way, where he talks about how your level of investment in an idea should always stay proportional to the level of confidence in that idea. And so you can see here, going from self-conviction, which is a very low level of confidence, all the way through to launch data, experiment data, and test results, you're much more confident once you've got real customer data to support your idea. Fallacy number 2, I should deliver more things. So the misconception here is that actually if you run more A/B tests or you deliver more things, your experimentation program is going to be better. When actually the truth is, the more features you introduce into your site, actually it's possible that the productivity of your users might drop off. And there's this theory that if you keep going and adding like an infinite number of features to your site, productivity of your users is going to start going down because there's just too many things on the site for them to interact with, and it's too confusing. They get paralyzed by the amount of choice and the complexity. A solution that you can look at is something like the Jeff Patton output versus outcome and impact, where you don't just focus on the amount of output, but actually what's the outcome and impact that you're having with what you do. So deliver less stuff, but make sure that stuff is genuinely valuable, and accept that actually sometimes it's better to deliver a better idea, but fewer of them, than to deliver lots and lots of little ideas or smaller things which might not have as much value. Another solution to look at is when you build an experiment, try and increase the number of things that you launch in the same experiment. So that could be adding more variations or just finding another way of introducing multiple hypotheses at the same time, because on average, the build effort, particularly for a full stack experiment, is about the same size for a 2 experiment test, a 2 variation test versus a 3 variation test. But actually, when you start getting up to win rates like 5 variations, you can definitely increase the amount that you're getting as your win rate. And this is from some data that Optimizely looked at, where they found that people who did experiments that had more variations in it had higher win rates. And if you think about it, it's a little bit like when if you own 1 horse and you put it in the Grand National and you only end up with potential for 1 winner out of 7, but if you own 5 horses in the Grand National, you've got a potential for 1 of your 5 horses out of the 7 to win. Another thing to think about is planning a mixed roadmap, so that you have a roadmap of different ideas, sizes, impacts, approaches. Some of them are simple, some of them are complicated. And actually, you can see this in the way that currently quite successful ideas have come to fruition, because people have explored ideas and had strategies for them that they've then abandoned. So if you think about how the iPhone has developed, stuff like multi-touch UI and multi-touch tablet that was developed several years ago that didn't lead directly to a product at the time, fed into multi-touch phone and the ability to build the iPhone in combination with things like the iPod. So you can see there that there were projects that people started, they turned out not to be successful, they pivoted away from them, and then ultimately it led to a more successful strategic product. Then finally, think about the value of your ideas at the same time as the velocity of your product delivery. And I'll come on to that when we talk about the real value model at the end of the session.
This is Romo Santiago from Experiment Nation. Every week we share interviews with and conference sessions by our favorite conversion rate optimizers from around the world. So if you like this video, smash that like button and consider subscribing. It helps us a bunch. Now back to the episode.
So fallacy number 3, which is my favorite one, or my least happy one, is the holy grail of prioritization frameworks is out there. And this is a real passion project for me. I kind of believe that people shouldn't marry themselves to prioritization frameworks perhaps as much as they do. And the misconception is that you have to have a framework to prioritize everything always, when in actual fact, it's quite unmanageable. If you try to prioritize all of those ideas in that spreadsheet that I showed you, you would be at it for like a day trying to get all the evidence you needed to prioritize those ideas. And then a week later, you might have to reprioritize them all. Every time you run an experiment or you do some product analytics on your site, you're going to reveal new data. And your next priority for what you work on should really change every time new results come in. Process is not a one-off exercise. So as you go through the flow of A/B testing, it's not I do it once, I prioritize once, I then execute. It is every time you run an A/B test, you need to be iterating and changing your approach and repeating and learning every time you go through this cycle. So it's not a single time that you try and approach building your product. If your experiments are not successful, they won't be fixed by better prioritization. You need to reevaluate your ideation and focus on your hypotheses, your goals, and your KPIs that you're using to measure it. Invest in the way that you plan your experiments, how do you ideate them, but also how you prioritize them using evidence. And one of my favorite ways to do this is using this confidence model built by Itamar Galad, where he essentially plots the confidence scores versus the categories of different levels of confidence on a scale. And one of the things that I always get people to do is to print this out, stick it above their desk, and every time someone comes to them and says, I've got a great idea, you just point at this and say, have you scored it? Have you scored it for evidence? Have you asked someone like whether that you've got evidence to support your idea? And if they don't, that gives them the opportunity to go away, have a think about it, and then come back to you with the idea when they qualified it a little bit better. It's a really good way of saying no in a nice way. But it's also a really good way of having people like step into the crux of the problem with you and try and have you help them find more data to support their idea, or do a little test now to prove that there's evidence to be able to do the experiment. And then you could do this much bigger project or much bigger experiment that requires more confidence to be able to launch it. So we've talked through the 3 prioritization and planning fallacies, like how things can go wrong in terms of planning out our experiments. But now I'm going to talk about the 3 statistical fallacies. So these are a little bit tricky, but hopefully people will get their head around them as I talk through them, and I'll use some visuals to explain what I mean. The first one is looking at results early, or peaking. One of the most common things that I see is that people try to look at experiment results before the experiment is finished. And the misconception is that at any point in time when you look at the result of an experiment in the UI, that you can interpret the result of the experiment or the statistical confidence through the experiment duration. And the truth is, you just can't. You have to analyze the experiment results at the end. In frequentist world, where you have sample sized your experiment to a specific size and you want to try and detect a certain amount of difference between the 2 variants in your experiment, you need to be analyzing the experiments at the end. The p-values of non-significant experiments, or where correct sample has not been reached yet, can take any value from 0 to 1. They could be jiggling all over the place. And I've got a graph in a minute that will explain that. And early on in an experiment, the data is highly influenced by the number of unique visitors in each bucket of the variance. So if you look at a results table like this one, you can see on this top row, there's only roughly 7,000 people in the experiment. It's showing a 22% increase in conversion rate to 99% confidence. Sounds fantastic, right? But it's only been running for 6 days, and the number of people in the experiment is really small. But if you look at a much lower row further down, like the one which is showing 34 days and a roughly 75,000 users, it's got a 3.2% conversion rate lift and 99% confidence. That experiment has actually reached sample size. It is powered enough that you can interpret this result. But if you were to just interpret the colors and just interpret the confidence level, you'd think, oh, this experiment's been running for 6 days, great, I'll just launch it. And it's not actually reached its sample size. You can't trust in that experiment result yet. Unless maybe the difference was like 100%, but then that would be quite worrying. So you would want to look into that before you actually launch that experiment. And then another thing that I've had some product managers do before is come to me and say, oh, look, really early on in the experiment, you can see the confidence level is fluctuating like this, like over time. That little dip in the middle, is that when there was a sale on? And so it's impacted the confidence of the experiment. And I said, no, this is just random fluctuation. This is just noise in the data. There's no signal here. There's nothing really going on. This is completely ignorable. Wait until it's reached sample size. And so in this case, the solution to try and prevent peaking is always interpret the results of your experiment with the help of a data scientist or data analyst. Sample size in advance and stick to that sample sizing as much as you can, unless there's a really good reason to turn the experiment off, like it's massively negative way before sample size and actually you need to stop having that experiment running on your site and potentially creating a negative experience for users. And then use something like a rule of thumb. So something I often do with product managers is work out roughly the right sample size that they need, and then say, right, this is about the right amount of sample size you need. Try and always aim for this, and then look at the results. And like, it's much easier to remember sample size, like a full rule of thumb, like 75,000 users, than to try and interpret a graph or try and interpret complex statistics. But there's some really good materials online. Definitely look at the work being done by the Skyscanner team. The Fourth Ghost of Experimentation, Peaking, is a great read. There's another article by John Nerona, which was originally on the Optimizely blog, but is now available on Medium, again, about peaking. And then also evanmiller.org. His stuff is fantastic. He talks a lot about the statistical impact of peaking at your results and what it actually means for your data. So there's definitely some great material in there. for you to look at. So the second fallacy is the higher the confidence, the more confident I can be. There's a misconception, particularly when looking at the results of frequentist experiments, that the more confident the statistical confidence is, the higher it is, the more confident we can be in the result, and the more confident we can be in the data. And if this value goes up and down, it is representing our confidence. And it's quite easy to end up with this misconception because there are stats engines out there where they have changed the way the stats engine works, so that it does show you the amount of confidence you have in the difference between the two variants. But in particularly tools like Adobe Target, where they just use like a standard t-test with a frequentist approach to analyzing the results, you will just be getting classic statistical confidence. And so the truth is, when you look at the statistical confidence value, it's important if it's reached sample size and it has the following properties. It's over the original threshold that you set for yourself, be that 90% or 95%, particularly for positive or negative lift results. If you're trying to get an experiment to prove that something is 0% lift, then you need to have 0% confidence. And if you look at the cumulative confidence graph, the shape is asymptotic. It goes over that threshold that you've set and it stays over. It doesn't dip over, go down, dip over, go down. Even if you get that right and you've reached that 90% confidence threshold, there's still a 1 in 10 chance of getting a false positive. So even if you've done all the things right, 1 in 10 times you might still get a reading when you haven't actually got a correct experiment result. So one of the solutions that I like to do to show this visually is to plot the cumulative confidence of the variance in an experiment. So if you look at this is an example of a winning experiment. It had 2 variants in it. The shape is so clearly asymptotic over 90%. And you can see that it trends up, it stays up, and it's there. So this is what a winning experiment should look like. If you look at non-significant experiments, we plotted every single one of our non-significant experiments, and you can see they're all over the place. Some of them go over 90% one day and then stay there for like a day and a half and then drop back down. They're up and down all over the place. And that's a way in which you can spot that an experiment is non-significant, is by looking at this visual and seeing that this graph is wibbly wobbling all over the place. And actually, we realized that by interpreting these curves in this really macroscopic level, we can start to spot where we might be tripping ourselves up and getting into a false positive, or accidentally get decision paralysis over non-significant results and deciding what to do. So the third statistical fallacy is that all metrics and segments are created equal, or rather, after an experiment runs, you can analyze any and all metrics and segments equally and expect good results. So the truth is, if you incorporate loads of segments and metrics into the post-analysis of an experiment, or into the post-analysis of lots of different types of validation techniques that you try and use, it creates 2 possible problems. One is what's called the multiple comparison problem, or the multiple hypothesis problem, and the second one is called Simpson's paradox. So I'll explain both of these really quickly now with some visuals. So the multiple comparison problem occurs when you incorporate many different hypotheses into a single experiment without accounting for the fact that each hypothesis needs a 90% confidence level. So each hypothesis has a 10% false positive rate. If you add another hypothesis, that's another 10% false positive rate. And if you look at the number of, say, metrics in a scorecard, if you keep adding metrics infinitely, like up to sort of 20 metrics here, the probability of getting a false positive goes up every time. It's a compound way that it's adding more probability of a false positive each time that you add an extra hypothesis. And so every comparison you make increases that probability. And so the only way around that actually is to use a type of correction. So, and I'll come on to that in the solution in just a second. But Simpson's paradox is a sort of statistical phenomena that happens when you look at things in aggregate level, and then you also look at them in segmented level, and you get a slightly different result at both levels. So for example, we segmented out and we got positive results in each of the individual segments, but when we looked at the overall results of an experiment, it was negative. And you may be thinking, how can this possibly happen? But it's quite common. Sometimes it's caused by a technical issue where actually the number of users going into each segment has been impacted by some other confounding factor that you're just not aware of. So for example, here's a set of conversion rates across Firefox and Chrome browsers, and then across both browsers. And you can see in the both browsers version, variant A1 because it was 80% now. It was 80 out of 100, the conversion rate, 80%. But if you look at the individual browsers, in the Firefox browser, B wins, and in Chrome, B wins, which makes no sense until you look at the number of people. So the number of people in the Firefox browser for variant B is only 20, but for Chrome it's 80. So there's something going on there where clearly variant B, people are not getting into the experiment variant in Firefox. And then on the flip side, people are not getting into Chrome in variant A, which is really weird. And so what you would have to do in this instance is actually fix the bug that's causing this to happen, that's creating this like paradoxical shift of people from one bucket to another, and then actually rerun the experiment. But you can still get this even if you haven't got a bug going on. You can have, depending on the segment sizes, segments that have a different result at a lower level compared to the overall results. And the main recommendation I would have is start by always looking at the overall result first. And when you start to look at the segments, make sure that they're actually big enough for you to be able to interpret the results in the segments, or plan for those segments in your experiment design. So the solution really in advance is, it has to be done in advance, sorry, is you have to choose the extra metrics and segments that you want to use in your experiment before building the experiment. You need to work out if you need any corrections done to your data, particularly if there's volume or quality issues with your data. And then if you do have good quality data in the right volumes that you know you can do the segments that you want to, it's not just there's only 2 people on Internet Explorer 6 that you want to analyze, for example. You can do what's called a correction using something like Bonferroni correction or Benjamin-Hochberg. There are lots of other examples of corrections that you can do, but this third ghost of experimentation with multiple comparisons has some of those corrections in there. So I would recommend reading that if you want to read more about that. The other thing is important is you should use the information to inform your total experiment sample size and test duration. If you think that you want to analyze lots of segments, you'll need to extend the duration of your experiment to make sure that all of your buckets get full of people. The other thing that you can do is you can do what's called stratification, where if you know that you need a separate clear result for desktop, for example, and a separate clear result for mobile, actually run 2 separate experiments and then let each one run until it reaches its correct sample size. And it might be that you've got hardly anyone on mobile and that experiment needs to run for longer in order to reach its sample size. So those are the 3 statistical fallacies, and then I'm now going to talk about the 2 experiment design fallacies. These are more around how you shape and build the experiment so that it actually works. So the first one is that starting high in the funnel always works. Sometimes it works, but it rarely works. And actually, if you plan a lot of experiments high up in the funnel, you might not see results straight away because there could be deeper conversion rate issues that are happening much further down in the funnel. And without optimizing those deeper pages for those stronger friction points, you won't get strong experiment results higher up in the funnel unless it's a really big, bold idea, like you were completely removing a whole page from the site or completely redesigned the whole of the homepage and the PDP, for example. So here's an example from Argos. This is a few years old, but the key difference between the 2, which is quite hard to see, is the one on the left has a simplified search bar. The one on the right, which was the variant, has a slightly improved search bar where you can see it says I'm looking for, and there's a little red search loop. So it's quite a small feature change. But interestingly, the one on the left, the winner was the variant was a winner for increasing interactions. It was a winner for increasing number of searches per user. So if those were your 2 primary metrics for this experiment, you're thinking, great, we won. But it was a loser for conversion rate. And the reason why is because the page that it was sending users to was really badly optimized. The search engine was not surfacing relevant results. So people would search for like Lego and they would get something else completely different or no results found. And it was because they needed to fix their search engine and the relevancy of the results that were being served. And so actually, people who would otherwise have gone through the mega nav and just found a product manually were instead searching and not able to find the product, so they weren't converting. And that's an example of where the shape of the experiment, really, you didn't know this until you actually got under the hood. But if we had started a little bit lower in the funnel and fixed some of those deeper conversion issues first, then potentially this experiment would have been really successful instead of a negative experiment. Another thing that's worth bearing in mind is that the expected base conversion rate as you go down the funnel gets higher. So the wiggly line is the number of users per step, And then the block graph is the expected base conversion rate. So high up in the funnel, you have really large volumes, but a small number of people who go directly from that page through the funnel and then convert. So the base conversion rate is really low. As you go deeper in the funnel, you're so much closer to the conversion point that actually the conversion rate from that page is higher. And so it's much easier to detect a difference in conversion rate and to be able to have impact on those pages. But also you're so much closer to the conversion point, and people have really high intent. They've invested a lot by the time they get to the checkout or payment pages. So they're really ready to convert. So if you can lower that friction level deep in the funnel, it will help people to get through the checkout, to convert, get to the order confirmation page. So as I was saying, start at the bottom of the funnel in order to remove the big friction points in the funnel. The confidence intervals there are narrower, customer intent is really high, and even a tiny incremental improvement leads to a better conversion rate. And then the second fallacy within experiment design, experimentation means you can ignore tagging. And actually, this is a big misconception. People often forget when they're running an A/B test that they haven't done the tagging on their site correctly, that they haven't looked at their Google Analytics and how their Google Tag Manager is set up, for example, or they've just migrated to GA4 and they have no idea how to report on their experiment in GA4, which is a problem that's coming up for a lot of people right now. The truth is, you have to really carefully consider on which page or which feature customers enter your experiment and tag that accordingly. You mustn't allow unaffected users not getting the experiment into your experiment results, because it will dilute your results and you won't be able to analyze the experiment effectively. You might have to rerun the experiment if you don't actually engage people like your engineers and your analyst early on in order to detect the potential problems that could happen. So this is an example from O2 Telefonica. This is from a few years ago when I was working with them. We launched an experiment where you could type into this box in order to look for a particular phone. And if you started typing 2 letters into the box, it would start showing you phones. Before 2 letters, it wouldn't show any phones, but only after typing 2 letters would you actually start to see the drop down. And on the left, inside the drop down, you've just got the control where we only showed the name of the phone. And then on the right, we showed fewer phones, but we showed an image and we showed the cost of the phone. And what was really interesting about this experiment is that when it was launched, we had some problems. And actually, the problem that we had with this test is that everyone on this page that have over 1 million users landing on this page was included in this experiment. But the number of people who actually type more than 2 letters into this box per day is roughly like 2%. So we are measuring millions of people to try and detect a change that's only being shown to 2% of the people who are actually in the experiment. So obviously we couldn't detect an experiment result. And so what we had to do was actually relaunch this entire experiment with a targeting application to, actually make it so that only people who do this action are included in the experiment, so that we can focus in and be able to measure the difference between these two. And so the solution here is to do your tagging, QA your tagging, and then QA your tagging again. And make sure that you feel really confident in how your experiment is tagged up and how you're going to measure it. And make sure you're only including those users who are going to see the experiment experience, and find a way of forcing the way that it's built so that you exclude users who don't see the experience, or then people are not activated into the test until they actually see the experience that you want them to. And so now I'm going to talk about the real value model, like a way that we can kind of look at our whole program and try and drive value through our experimentation program. So imagine that you have got 3 teams who are just starting experimentation. They're just starting to build their first product experiments. And the teams have decided that they're going to go after different objectives. One team is going to focus on these bigger projects that are more complex, have potentially higher impact for the customer and higher value, but potentially fewer experiments per month. The next team is going to do sort of medium-sized complexity experiments. It's going to have quite a bit of value, but they don't think it will have as much value as these bigger projects that the team 1 is working on. And then team 3 are kind of going to work on the quick wins. They're going to work on the small experiments that keep churning them out, do lots of experiments per month. And you can see here the number of experiments per month is probably only 1 experiment per month for team 1, 2-ish for team 2, and then 4-ish for team 3. And if you plot that, you can see that team 1, which is the green line, they get 4 experiments in 4 months. Team 2, who are the blue line, get 8 experiments, and team 3, who are the yellow line, do 16 experiments in 4 months, which is quite a lot of experiments. That's like a really high experiment velocity. If you look at how they've improved conversion rate on the site, however, if that's their primary metric, then team 1 are actually absolutely outperforming everybody else. If you assume a base 20% conversion rate and you take that 10% lift on top of 10% on top of 10%, then after 4 months, you'll have 13.7% lift total end-to-end ROI from the program. However, team 3, who've only been doing these little 1% lift experiments, they're at 4.0%. So they're nowhere near delivering the same volume, of value within the same amount of time. And if you actually plot velocity versus value, you can see that team 3, who are doing so many experiments, have achieved 4% lift off of 16 experiments, but team 1 have done 4 experiments only, and they've achieved much more lift. So thinking about your experimentation program with this zoomed out way in order to actually be able to deliver more value, it's about picking a mixture of different experiment sizes, but always trying to push to do something that's a little bit more impactful, to do something that's going to drive a bit more value, rather than just focusing on output, rather than just trying to drive, we must do 2 experiments a sprint, every single sprint, no matter what. Be more flexible. Make sure that each time you're doing a sprint, that you're delivering an experiment that's of a size that's worth delivering, that's going to have impact for the customer. So to summarize everything that I've just talked through, don't get paralyzed by your prioritization. Embrace the possibility you might get it wrong, but you'll learn. Be open to pivoting away from an idea when you get new evidence. Check your statistics and your tagging, and then check them again. And finally, think about how you in your program can optimize for value versus velocity. Every product team and every team running experiments is different. So what version of the model that I've just presented is going to be right for you, for your product and your team? Thank you very much for listening. That's my session at the Experimentation conference. And I look forward to seeing you all at the next event or the next session or sometime in the future. Thank you all very much for listening.
This is Romo Santiago from Experiment Nation. Every week we share interviews with and conference sessions by our favorite conversion rate optimizers from around the world. So if you like this video, smash that like button and consider subscribing.